Okay, so my name is Terry. We're going to learn a little bit about Get. We're going to just be skimming the top right now. It does get a lot. Later on, we're going to be starting to get into the fundamentals of how to go into a multiplayer experience. So when a lot of people come together and conglomerate on a single project, that can get rather messy. So we're going to gloss over that. But from now on till the end of time, whenever you do something for more than, say, 10 lines of code, I want you to start getting into the habit of using Get, okay? Or if something's tricky, just because your code is 5 lines, if it's something very tricky or something you're super proud of, go ahead and put it into your Git repo. All right. So, the guy who made Linux, Linus Torvalds, he was the guy who first started this. He was the one who thought Git was the best thing since sliced bread. A popular version control before this was that everybody would come together with a file and it would get locked by the first person who had rights on it. So if I wanted to do this file and he wanted to look at the files, whoever called dibs on it first got to modify the file. That's how version control happened. Everybody had access to one file and that was the file that everybody got. Git is a distributed version control, so that your copy of Git and your copy of Get is different than my copy of Git. And then we push it up to a master, which is the one everybody's going to bounce off of at any specific time. Okay? Does that make sense? I'm going to draw a picture real quick. So this is going to be master. This is my version. And this is your version, okay? This could be up in the cloud, this could be on somebody's computer, this could be anywhere. Notice these are not the same at all, but we're going to bounce each other as a master and we're going to reflect that. But before then, we're going to take your version out of it and the master version out of it, or actually, we're only going to have a master version. I'm sorry. And that's the only version we're going to talk about. That allows us to do several different things that we don't have to worry about, but we're going to get into that later, okay? Before we start, I'm going to give you some simple Linux commands. If you don't understand what a thing does, please let me know because I'd like to explain it to you before you do it. But these are most of the ones we're going to talk about. CD is change directory, ls is doing a list. We're also going to use that with a flag, -a, to look at hidden documents. Things in Linux that start with a dot are hidden. You can't just see them unless you do a -a to list it. Copy is to move a file from place to place without removing the first version. In order to make a folder in Linux, you're going to call make directory. Echo is to take something from the command line. And then the last one is we're going to redirect that echo output into a file, okay? This is all going to come in later, but I'm just doing a real quick glossing over what's going on, okay? Now, inside the command prompt, we're going to be doing all of this from the command prompt. We're about to going to do this live, but when you first start, on your command line, I want you to do a make directory and then a folder, okay? So you can call it git, test, something, I don't care what it is. But I'm going to do this with you guys in a second, so don't worry too much about it if you get lost. We're then going to do stuff. We're going to actually make a folder. We're going to make a file. We're then going to change the file. We're going to commit the stuff. We're going to add it and then commit it. And then if you run into problems later, you can always call git --help or git man git hyphen and then the command. So Git has its own version of several Linux commands. So if you want to copy something, if you want to remove something, you want to move something, you can do a man -get and then look for what you need, okay? So let's go ahead and get in terminal. I'm going to call mine get class. Okay, now let me move this over here. Get init is always going to be the very first thing you do, okay? But for a point, I'm going to type ls and nothing, or ls -a, and nothing comes up. Dot is the local folder, which is where we are here, and the 2 dots is the folder above. It's just the way Linux does things. Now I'm going to type get init. That initializes this repo. So when I type ls-a, I now have a git folder. That is where your version control is happening. It means this is a repo. That's how the system now knows that I'm about to do stuff. If this doesn't show up, that's fine. That's a different class. We can go over that. You can always get with me later. All right. So now let's go ahead and make a folder. So we can go ahead and type vim and now we're going to type stuff. Stuff. Okay? Okay? So what we've done is we've just created a text document that's called example. Okay? Is everybody with me so far? You've got something there that is stored. Now the next step is to do this add. And I want you to explicitly say after your add what you're adding. You can do some shortcuts later on, but I want you to focus on that later. Right now I want you to be very specific on what you're adding. Okay? So notice that I now have add something and we're ready to commit. So now we're going to type we come up here. So now, usually this very first commit is going to be initial commit, but this is specifically for you. What exactly is your saving? It's vital for you to come up with a good thing for you to come back from. So if you're writing a Carla class assignment, you could just say, display now works, or sort is broken. We'll stop compiling at this line. These are useful for you so that you can always go back to this issue. These are just snapshots of time where your code was developing, okay? Yeah.
How do you go in and out of insert mode again?
Say that again?
How do you go in and out?
Oh, type I to get into insert mode and then escape to get out of insert mode. Yes.
What did you do after add example TXT?
Here, let me right quit out of this. So what we did is we did the example. We then did a right quit. And then we did git add example.txt. And then we did a git commit.
Okay.
And that'll throw you into that Vim thing, okay? And then after you write your blurb, you're going to have that commit, okay? Now, at every step, you either finish a function, you compile, you do some tricky bug troubleshooting, stuff like that. I want you to do an add and then a commit, okay? So that snapshot is now saved. Later on, when you're at the next step and something goes disastrously wrong, you can always go back to the last stage. That's the beauty of this. You can actually see what's going on. So we're going to add another file. So let's do a oops. Okay? So we've now created a new file called example2. How do we track this file? What are the commands we use?
Git add,
Git add,
git commit.
and then git commit. And then we're going to say this one is okay. So now we know that each of these files are now being tracked by Git. But kind of how is that useful? So one of the nice things to look at is called get log. This will bring up this, where it'll actually give you a hash of everything you did. We are currently on branch master. And the date you made the commit, the person who did it, and what you typed at that snapshot in time. Okay? Does anybody have any questions on this? I know this is really kind of on the simple. We've only talked about 3 or 4 commands, but this is the bread and butter of how to do this. If you can do this and stuff goes horribly wrong, you can come and talk to anybody and say, I ran into a horrible, horrible mistake, but I'm using Git. And we can then revert you to prior versions. We can give you how to merge these things. There's a lot more we can do to help you in a situation where stuff has gone wildly out of control than if you don't do this. Yeah.
It says I have untracked files.
Okay, just do a git add and then the name of the file that's not added. So another thing you can do is type git status. That's another one real good. It'll actually tell you which files are not being tracked and which are. And then if you're in the middle of an add or a commit, it's a very simple way to kind of check on that. All right. Anything else? Is everybody kind of at this stage? Okay. Now, let's go ahead and make a change. We're gonna talk about a git log, a git diff. We just kind of touched on the git status. And then we're going to talk about a git ignore. Okay, so let's make a change to example 2. So we can just go ahead and type vim example, or actually, yeah, example 2.text. So we've got more stuff, and let's call it different stuff. Or you could put anything in here. The importance is you just make a change to this. And then do an add and commit. Yeah.
So on the commit comments, at a certain point, Vim does some stuff where like it changes the cursor. Like, is that like because it hits like a certain comment length? Or?
It's hitting the end of the row and it's wrapping it for you.
Okay.
It means nothing.
Okay.
You can always hit enter if you don't want it to go that far. Rarely have I needed to write a paragraph of what I'm doing.
Right.
Usually it's either if the status is not currently working, I start it with broken. And then whatever functionality has been added. So usually it'll be add display or broken display, fix blah, blah, blah. But this is for you. If you want something different, then that's all for you. Okay? Now, I want you to do a get log, and it's going to say, here's the 3 commits. Now, let's do the get diff. So we're going to type get diff, and then copy and paste these hash functions. Oops. No, you're going to have to right click and then paste. So highlight it and then copy and then paste. And then same thing with this one. Copy and paste. Okay. So this tells you what the difference between these 2 files. We've got A is example2.txt and B is example2.txt. So we know we're looking at the same file. We see that these are the files that has changed. This is the older version, which means it has less than what B has. B has more than what A has. So we know that they both contain this item because nothing is negative and nothing is positive. Nothing has changed between these 2 files. However, this is different because B contains different stuff and A does not contain it. That's why it's got that negative and it's in red. Okay? This comes in very handy when you think you haven't made any changes, but it's all of a sudden broke. This is the first command that I'll go to in order to find out. What is very common is because we're using Vim, sometimes letters just appear in the middle of your code. If you do a get diff between it's working and it's broken and it shouldn't be different, differences will become glaringly obvious right here between where I am now and where they used to be. Like all of a sudden your first character is not a pound sign anymore, it's an exclamation point. Well, why did that happen? Don't care, but we now know the difference. And if you're looking at 1,000 lines or more, finding the one character where Vim accidentally did it, because of course you wouldn't do that, it's very handy. Okay?
So if nothing pops up, then that means there's no difference.
If nothing pops up, there is no difference, yeah. Okay, does anybody have questions on this? Okay, we already kind of talked about, yeah.
So does it tell you somewhere the exact line where things are different, or am I missing?
I think that this middle part does, but
Okay.
is where you can go.
It'll just tell you if things are different, not necessarily what's different, other than something has been removed or something has.
We're doing a toy example. When you actually do this, it will have more information to narrow it down. I've had to use it before, and it's never been an issue. I think it's pretty intuitive, but I can't remember the exact way it narrows it down in on it.
Yeah.
And at the end of the day, you can always do a search for what you're looking for too. Yeah. Okay. Okay, so get status. That'll tell you the status for what is being tracked and what is not. Now, we're going to talk about a .getignore. So inside your Git folder, you can create a .getignore. I would highly recommend doing that at any time you want to not have specific files. So if you're pushing to a repo, perfect time to add a .getignore. When you're doing different programs, you can add that so you're not actually tracking your a.out files, because you don't care about your a.out file. You care about the code. You can always compile it later, but who cares about your latest version of a.out? Config files. This is the vital part. If you don't pay attention to those 3 examples, at least remember this. You can lose your job. You can be put in jail if you put your config files where they do not want to be. Okay? Every time in the headlines, there is somebody who put keys in their Git file, and it's a bad thing. Okay? So what you do is you put your keys in an external file, you add that file to the .getignore, and then you never have to worry about those getting pushed to the repo. Okay? So your private keys should not be a part of your Git repo. Make sure your file name is part of the .getignore if there is any chance at all that that's a problem. API keys, same thing. For every time you send a query out to a huge database, you're probably going to add a key, a specific text file, in order to say, yes, I am authorized, this is who I am, allow me to do this. But if somebody impersonates you with that key file, it is your fault. It's very simple to do this, but it's also very easy to forget. Because if you hard code it, just don't, okay? Just don't. Let's make it simple like that. Same thing with your swap and your SWO files, okay? When you're opening up Vim and you background the process and you go ahead and do a commit, you obviously don't want to care too much about your swap and your SWO files, okay? Any questions on that? Okay.
Actually,
Yeah.
Are you in the .getignore? Do you just type in the file name like?
You're just going to have to create it. So you're going to just vim.getignore, and then it's going to have the files that you can do. You can also do a regex. Yeah, you can do a file names. So usually I'll make the keys a .text file. They're going to be the only .text file because I'm the one designing this program. Or I might have to do something fancier. I can make it a config file and just make it ignore all .configs. It's completely up to you. However you want to set it up, you're just going to put that in there. Okay? So, getting set up for multiplayer. This is where you're going to be working with other people, where it's not just you working with master, it's now you working with other people. Okay? So, if you actually push to a repo, it's going to give you an error that says, hey, I don't know who you are. So if you noticed when I did my log, it had my name and my email address. Did anybody else have theirs name and email addresses pop up? Okay. Sometimes the school computers will do it, but if you push to an external one, it'll specifically ask for these two pieces of data. Your username, or whatever you're going to go by, and your email address. Okay? So that when you're adding code and somebody needs an explanation of what's going on, they know who to go to. So if, say, 100 people are both working on this, like imagine we're coding for an operating system and there are a ton of people on this project and there's a line that we have no clue what to do. And it is now years from the person who wrote the code to now. We can at least talk to somebody who knew that person. Okay? So that's what this is for. When you first start pushing, it's going to actually ask for that information. Okay? And then sometimes you're going to want to make changes. The school automatically sets this core config up. If you start working for the cat, though, you're going to actually have to set this up because it can make your life interesting if you get into an Emacs mode and you weren't expecting it. Okay. All of these changes or more are stored. So the tilde means it's in your home directory. And then do a backslash and then a .git config. Okay. So if you can go ahead and actually set that file up, and Git will actually look in that file and set your changes, okay? Does anybody have questions on this? Okay, now we're going to talk about branching. When you first start doing stuff, very rarely are you going to have direct access to the master branch. You will have a copy of it because you'll download it off the internet and say, this is my master, but then you need to make changes. The whole point of this is for us to make changes and then bring them back together. So what you're going to do is create a branch. So if you type in your folder git branch practice, you'll switch from master to practice, or you won't switch, but you'll create a branch called practice, and then do git checkout practice. Okay? So what you've done is from master, you're going off and making a practice. Okay? Changes done here do not affect changes here. That's what the version control is. So if you go and destroy practice, nobody cares except you. Because master is still working quite nicely. It's just your stuff is broken. You can also do the git adds and commits in this all the time. And it's not until you integrate this practice back into master that this is now master. Okay? So that when I come in and I have my version and I'm making changes to this, your changes do not conflict with mine until we try to merge them with master. Okay? We're going to get with merge conflicts in a bit, but that's kind of the basics of how we're going to do this. You're going to take master, you're going to make a personal copy, and then you're going to make changes and then put them back into master. Okay? Yeah?
So how is it supposed to merge properly?
We're going to talk about that, and sometimes it's fun. Okay? Okay, is everybody on branch practice now? Okay. So now let's do a real quick we're going to just work with the command line. Instead of using vim to create testfile.txt, we're going to use echo. So echo, testing, redirect the output to textfile.txt. Then type ls to make sure that nothing went wrong. And then you're going to do an add, commit, and then a change. Okay. Let me know when you're done. Okay? Yeah.
So after creating the practice branch, how do you actually get into it?
Oh, checkout practice. Get checkout.
Oh,
Get checkout practice. Yep. Now you're there.
Okay.
So after we commit, do we need to enter anything to the file?
Okay. So what I want you to do is after you do that, you do a commit and then a merge. I want you to go ahead and vim the testfile.txt, and under testing, I want you to just type, let's say broken code. Just type in broken code, and then save and commit, and then I want you to do an add and commit. Yeah.
When I try and merge, it just says fatal, no remote repair branch.
Are you did you do a checkout onto practice?
Yeah, I'm in practice.
When you try to commit it, it also says the file's untracked.
Oh, okay.
Yeah, I added it and then committed, but when I try and merge it, it doesn't want to do it. What is the remote?
Oh, because you don't have that file in the other one. We're
Oh,
don't
cool.
you're too far ahead. That's all right. Okay, what's
Same
going on?
thing for mine.
Oh yeah, don't worry about it.
Okay.
Don't worry about it. Yes, it's not going to work at this stage because we haven't. I guess I should put that on the next slide. Anyway, whatever. I'll figure it out later. Yes. Are you?
No remote for
Yes, okay, I'm sorry. I'm gonna fix that. Okay, so now what I want you to do is type git checkout master. All right. Well,
So then it switches us back.
so we were at practice, we're now back at master, and then I want you to type, just do vim testfile.txt, and then type testing, and then type on the next line working code. What we have done is on the same line, we have broken code at practice, and we have broken code at practice and working code at master. Okay? Now, make sure you do an add and commit for testfile.txt, and then do a git merge. You're going to get an error that says, hey, there's a problem. These two things don't seamlessly connect.
So we add the test file, then merge.
No, you have to add and then commit.
Okay.
It's not going to, if you don't commit, it's not going to care.
Okay.
If you add it, you're staging it in a situation where this is the file you want to do it, but until you commit it, it's not going to actually save it.
Nice. And do I have to type in the test file.txt after?
Yeah, so git add testfile.txt,
Yeah,
and then do the commit.
And then after the like git commit test file.txt or just git.
Just git commit. So what you're saying is, hey Git, I want you to track all of these files, and that's what the add does. And then commit says this is the snapshot that I want you to keep.
Oh, I see.
So you could type git add, and then you could modify stuff, and then commit.
Okay.
But let's just go with the flow. Okay.
Did you say to do a merge as well?
Yeah, so at this point, when you do a git merge, you should say, it should give you a warning that says there was a merge conflict.
I'm still getting the no remote for code brand.
Are you on merger practice?
I'm on master. Should
Okay, so make a new text file.txt.
test file.txt.
Yep. And then under working code, I want you to type, or did you put testing on the first line of the first one? Oh, did you do an add and commit? Actually?
I did. For this one, I just wrote working code.
Oh, so you do an add and commit,
Okay.
and then you'll be able to merge. Because until you actually do an add and commit, it doesn't care.
Oh, okay.
So in practice, you do have the test file.txt, but there's nothing on this side to merge the two. It doesn't know if you want to call it something different. It doesn't have a binding feature to bridge the gap between the two. Okay? So this is where it becomes tricky. So whereas you're working by yourself, you only have to worry about 3 commands. We've already gone through half a dozen on a kind of nice flow with more than one person. Okay? That's why it takes a bit of time to go from one person to more than one. For you yourself, when you're coding, absolutely, definitely do those 3 things. Make sure you take snapshots on specific occasions and go through those. When you get done with school, you are just going to start learning to use Git. Git will never go away for the entire time you are coding. It is I was talking to a head person Saturday, and he said, I will be able to teach you the tools that we are using specific to us. However, the fact that you know Git makes you head and shoulders above most people, because most people in school do not use Git. So if you can put on your resume that you know Git. I actually went back and put it on my LinkedIn profile and on my resume that I've used Git, because I was like, whatever. But no, this is vital. This is vital to industry wherever you go. More than likely they will use get. They might not, but the commands will be more than the same. More than just a little bit the same. Okay, there are very few projects that have a version control where they actually lock the files. There's like one or two things that use it. It is very rare. Okay. Okay, so now we're at the get merge and we're at the conflict. Okay. So what we need to do is we understand where the conflict is happening. In your master branch, go ahead and do vim test file. You're going to see it looks very different.
So I'm in master and it still doesn't want to merge.
No, it won't, because we haven't resolved the merge conflict.
Yeah, okay. But I never got an error for the merge conflict, so
Oh, did it work?
I don't think it ever merged. Am I doing get merge while I'm in master or while I'm in practice?
Oh, I'm sorry. Try to do a get merge practice and master.
Oh, you type the two.
Yeah,
things
you have to
want
tell it what to
Okay.
merge with. I'm sorry. Yeah, I should have gone with that. And I don't ever talk about that.
Wait, so
So do get merge practice master. Let me see what that does to you. Yeah,
I got
that
it.
is
Yeah.
exactly what, I'm sorry, yes. I should have put that on the board. So you have to tell it what branch you're merging into master, okay? So, yes?
telling me that I have a conflict.
Yes, that is exactly what we want to do. So now go ahead and do vim testfile.txt, and you should see something about head, and then a string of less thans, some code, and then an equals bar, and then stuff like that. But that is the section that's causing the conflict. If you're in a huge long string, search for those a string of greater than, less thans, equals, or something like that. But this is where the conflict is happening. Zero in on this is the problem. Okay? So to resolve this, all you have to do is get rid of the head and the end, those greater than, less thans, the part that we want. So I want you to go ahead and delete everything except the part that says working code. Okay? So we have taken apart the stuff that Git had added and the broken code. Okay? Then when you get out, you're then going to add testfile.txt, and then you'll be able to do the commit. And then you can do the merge. Okay. Now this is why you have to be very careful when you're taking care of merge conflicts. This is about the simplest case that we can. One line said one thing, another line said something else, and we knew exactly which one we wanted to target in order to fix that. Sometimes it's not so clear cut. So if you write a line of code and I write a line of code and they do something about the same, that still might cause a conflict though. So we need to choose. Which version do we want to go? Which will become the master version? Which is the part of code that is the basis for everybody else's line of code? That's the mentality we're working with here, okay? Has everybody gotten the merged those files? Okay, what's going on?
So it says that you have not concluded your merge. Like when you merge.
Okay, did you do an add and commit?
Yeah, add and commit, and I did the practice and master merge, and then it says fatal.
Okay, do Vim test file again. Oh, you, put the first line in testing.
Oh, okay.
So it sees there's more different than what it was tracking.
Testing.
And then do an add and commit.
And then, cannot do a partial commit.
All right, go ahead and do, you can do an abort. So get merge and then hyphen abort.
Like that?
Yep. And then do an add and then commit.
And test
Nope,
file.
nope, nope. Get add
Oh, okay.
test file.txt
Text.
and then get commit
Commit.
test file. Okay,
Okay.
you're good. All right, yeah.
So it looks like once the merge is done, the practice branch doesn't actually close down. Is that the idea that you just
Yes.
go over to that branch whenever you want to make changes and then eventually remerge with your master?
Yeah, whenever you merge, you now know that these are the same.
So whenever you want to edit from master.
And then you can always make more changes here.
Okay. So whenever you want to edit from master, you don't want to make a new branch every single time. You just
Unless you want to.
Okay.
It depends on your workflow. So here at the CAT, when I'm doing updates to security stuff, I'm going to specifically make a branch that says I'm about to make a security update with my username and roughly a quick description of what's going to happen. After I'm done with this branch, I then destroy it. As soon as I know that this request is, so I have no access to master. I push a request up to master, and then it's tested. As long as the tests go well, it is then merged with master because we're not going to put broken code in master. We're going to test it, make sure everything's working, and then we're going to merge it.
Okay.
But if you are just adding more and more functionality between teams and you just want your own private branch, you don't really need a new branch. It's just for us to make different version controls, we can use that. Yeah.
If you're merging master and practice and want what was added in practice, do you just move it into that head section?
That's exactly what you don't want to do.
Oh.
You're defeating the whole purpose of
Okay.
this. So
you never want to
so-
change the changes.
So think of it this way. You're doing your personal copy and you're asking permission. So let's say I'm the master, okay? I'm controlling master and I have 5 other people and each one of you has your own version of stuff you're working with. So you're going to say, hey, I want to merge mine. You're going to do a merge request with me and say, hey, test and make sure this works with everybody else's code. And I give you a thumbs up or thumbs down.
Okay.
You're asking me for permission. I don't care what you do with your personal copy, but the thing you're sending me needs to be able to interface with master so it's always working.
Right.
And that's the beauty of this. You're not going to ever touch this code. You're saying, hey, does my code seamlessly fit with this? And then I'm the gatekeeper. I'm the one you're going to face if suddenly stuff is broken.
Okay.
I'm not going to touch your code. I'm going to just make sure its functionality is compliant with the rest of our code. Okay? That's why I'm not going to copy and paste your code from somewhere else. It's supposed to be able to seamlessly integrate. So if we didn't actually cause that problem, if we just added a line, it would have just merged seamlessly. It would have worked fine. It would have had no implications. So no problems. It's when there's a merge conflict, we're going to see what's going on. That's when the hands-on stuff. Okay? Any other questions? Okay. So I'm going to talk a little bit about doing this stuff online. However, we're going to be glossing over a lot of this stuff. If you want to have something very specifically done, we can talk about it. The reason we're going to be glossing over it is if we do this for real, I can break your stuff for a different class. Okay? So a lot of people want to do this online. I understand that. When you are going to a job interview and you want to be able to show off your coding skills, it's very important to be able to just go, hey, here you go. So I highly recommend you to start a Git repo and to start pushing stuff over there. Make it private for now. Later on, you can make it public for different situations. Okay? So in order to talk seamlessly with the web, you're going to do, from the command line, SSH-keygen. Okay? This is where part of the problem can happen. So just be careful with what you're doing. It is going to make what's called, by default, it's going to make an RSA key. Okay? I don't want you to actually type any of this right now, but I do want to show you what can happen when you do this, okay? So I'm going to go to my home directory, and there is a hidden folder, because we're using SSH keys, called .ssh. Okay?
Wait, how did you go to the home directory?
I type cd space tilde.
Okay.
That takes me there. All right. Now, as you can see, there's a config file. There's an RSA. There's an RSA.pub. You should have just the RSA and the RSA.pub. Does anybody not have those two files there?
I don't have anything.
Okay. Then we could very easily do it on your machine because nothing is dependent on what we're doing. However, I have more than a couple. It's because a few of the classes that I've been in require an RSA key. So I'm not in the cloud class anymore, but I am using the GitHub, and I'm using the 551 and stuff. So in order for me to talk to these people, I have the known host file. I'm sorry. So these are all computers that I talk to on a normal basis. As you can see, I talk to a few of them. What this does is SSH says, I have identified a lock. When you first SSH to the school computers, did you see the RSA fingerprint identified? Yes or no? Is this something you know? This is a simple check to say, is this fingerprint correct? This is a security issue. If you really wanted to go the extra mile, you could actually call up the cat and say, hey, is this RSA fingerprint correct? Because I'm worried I'm connected to something wrong. And that's why you have to explicitly say yes or no. Do I trust the computer to be the person I'm supposed to be talking to? Because you've got a lock and a key, and as long as they match up, you're good. But they have to match up. You're sending the lock to somebody else, and you hope it's the right person. If it's not, you've got what's called a man-in-the-middle attack, and we can always talk about that later, just to give you broad strokes of what's going on. And then I also have to set up a config file. So when I go to Bitbucket and say, this is me, I actually went to bitbucket.org and said, this is my public key. You're going to see it up at the top that one of these options will actually match Bitbucket's servers. This specific key is the key that I want you to match to their lock that's in the other file. Okay? And if you don't have this set up, so when I talk to GitHub, I want you to use this file for my key, and it's going to be one of those files above me. You're going to match those two up. And the same thing with GitLab. Okay? What is also nice about these, if one of your keys becomes compromised, you just generate a new pair. You're already going to have the same lock, but you're going to send a new lock to them because you're going to have created a new key. The two need to match, and then they're going to match in here. Okay? I know we went over quite a bit. Yes?
Sorry, so this key and lock, is it used to access the master copy? Or?
This is how you talk to the server, so you have trusted communication.
Oh, okay.
This has nothing to do with Git per se. This is how do I talk securely with the person I'm talking to over an unsecured network.
I see.
Okay?
Because it's a public server, right?
Well, the internet is pretty much public. It's one of the ways. So what you're doing is you're encrypting the data, and you're saying, hey, this is how you're going to unencrypt my encrypted data. So your key is going to encrypt the data, and their lock is going to unencrypt it.
Oh, so that's why it's important. Like someone steals the.
Yeah, so if somebody steals the data en route, which is very easy, they have a bunch of data that is useless garbage to them because they don't have your private key that you use to encrypt it. That's the basis for what's happening here. Is it's a lot easier for you to give them a lock, and as long as you keep your key private, there's useless garbage coming between you and them. Okay? All right. Does anybody else have any questions on what we're talking about here? Okay. But that is kind of the foundation of what you would need to set up for when you're playing around with more than a few people. Okay? Git clone. This is usually how you would get into it. So when you very first start, you would do a make directory. You would then find where the master is, and you would say git clone whatever. Usually it's either a website or an SSH place. So if you go to my GitLab repo, it's like Dark Tower Cat at something at gitlab.com, something like that, okay? Whenever master changes and you want those changes to reflect with your personal copy, you do a git pull. So let's say you do a git clone, you do git clone once, and that gives you your instant snapshot. You then go to sleep, you don't make any changes, but 5 other people worked on master. You're then going to do a pull request, git pull on the same thing, and now your personal copy matches again what master is at that time. Yeah.
If you've made changes that you don't want to get overwritten, will Git pull do that?
It will tell you that that's about to happen.
Okay.
So usually what you do is you do a git push and then do a git pull.
Okay.
Or you can do a pull and then a push. But either way, you want master to do it. If you create a conflict, it's going to say, hey, there's a conflict. Okay. And then you can always resolve it. And so once you make your changes, then it's a git push that's there. Okay.
So is a git push like a merge, but you have to get access?
Yes, you're requesting a merge.
I see.
Yeah. That's the explicit, hey, put my code with yours.
Make sure this isn't going to mess
Yeah.
it up.
As long as there's no conflicts, it will do it automatically. But it's when that conflict happens that there might be a thing. Okay? If you want to learn some more stuff, I've got a cheat sheet right there. So copy everything in that folder to your home directory is what that means. If you want to send me an email, you want to do that one-on-one setup type stuff, we can also talk more about the SSH key thing. Let me know, okay? Because the reason why I went over that kind of glossy is 1, I don't want to break somebody's stuff, and 2, not everybody needs all of that infrastructure that I have. However, I am a part of the CAT, I'm also a part of the ACM, so I have to have access to a lot of different school computers, and that doesn't even count for the class stuff that I have, which is my stuff, which is why my stuff looks weird, okay? But we can definitely do this one-on-one. Depending on your specific situation, we can get you set up. And since we'll be one-on-one, I can make sure that your stuff works. Because the last thing I want to do is get you set up so you kind of understand it, but none of your stuff works. Okay? Does anybody else have questions? Okay. You're welcome. Yes, yes.
I have a question.
Yeah,
So I
yeah.
should always push to master, right? Just to overwrite. I'm just.
Yes, yes, absolutely. That's how you solve. That's how you solve problems. Yeah, that's how you solve merge conflicts. But that's how you real life conflicts.
So can you have like a setting on your GitHub, so even if there isn't any conflicts, when you push, it's still
Oh yeah,
reviewed by
absolutely.
another person?
Yeah, absolutely. That's actually pretty normal
Yeah.
because
I figured there'd be like the person who checks other people's
Yes.
stuff to make sure.
yeah, like for the cat when I'm pushing, it doesn't matter how little the change. It doesn't matter if you add a comment.
Right.
It is seen by a person. Somebody lays hands on your code and looks at what the difference is, and does a mental note. So when they look at they will actually use the web interface, and it specifically shows your code next to everything else surrounding what you did.
Yeah, it's like a really high-tech Git difference. Right?
Yes, exactly.
That's all the different
It's
things.
pretty cool. And then if it makes that sense check that yes, your code looks visually okay, they will then grab one of these machines in front of you and run your code on that machine to see if it's broken. If it passes that, they will then merge it with, so it will then affect all of the computers.